Hey there, my name is Chris Fernandez for Keysight Technologies. Today I'm doing a short video on a small standard as part of our TSN solution testing. Today I'm going to be focused on 802.1 QBU, which is frame preemption. We work on many features including TSN. So for today's demonstration here, I'm going to be using IxNetwork, pairing with an NXP switch as my DUT. As you can see, Keysight provides a bunch of solutions in terms of hardware and software for validating TSN implementations. So today I'm going to be looking at the frame preemption tier 802.QB1 and one aspect of it. We also have a test conformance packages. They are fully automated and part of KNC, which is called Keysight Network Conformance Tests. And they have different parts for automotive, industrial silicone testing, and we have also a special part of that. So one user case of the fragmentation. Usually there's two use cases for frame preemption that we tend to look at and able to actually test using IxNetwork. One is to actually send preempted packets and look at the DUT capability to reassemble those packets and looking on the other side if that was okay. And that's what this drawing here represents, us sending fragmented packets. But today I'm going to look into this use case number 2 here, which is the DUT's capability to do fragmentation itself. So for that, I'm using IxNetwork on the left here, and I'm using 3 ports, one for express traffic, the other one for preemptible traffic, and another one for egress traffic. I do not have flow control enabled, so even if I would, it's not what that I'm doing here, even if I would oversubscribe the port, I'm not going to be seeing any MAC frames here and MAC pause frames. So that's disabled, and I think that's by the standard is TS or any flow control is not enabled. And as part of a layer 1 configuration on our ports, under frame preemption, we're going to enable frame preemption and respond to SMD requests, which is not really necessarily what we're doing here. For this demonstration, we're not sending fragments. So in terms of traffic, I have 2 traffics. One is called express, which is our critical traffic. And I'm sending 64 byte packets, 500 meg at 500 meg, and 10,000 of them. I'm doing a start delay here of 500 milliseconds. That's to give a little bit space. So we're going to see flow of the non-critical or preemptible traffic going first, and then 500 milliseconds later, that's when we're going to be sending the critical traffic. So we're expecting that traffic is going to preempt or going to kind of pause the non-critical traffic until all our frames are over. Then it's going to resume the non-critical, and the non-critical at that point, if there is space, we're going to fragment it. So we're going to be sending the non-critical as fragmented as we send our critical traffic. We're going to see that on the capture. And in terms of why I chose to put an IPv4 in here, that's not really not necessarily, but I did that so that the flooding of packets don't happen. So it is a switch. So a switch learns MAC addresses based on what's coming from that port. So by adding the IP layer here on my configuration, and when I bring that up, the switch is able to learn which MAC address belongs to which port. So flooding doesn't happen to the switch, and it doesn't interfere with our testing or our what we expect on the ports. So now for the implementation on the NXP, I have here in the screen the configuration, the full configuration for the NXP. On the left side here is just the basic configuration, which is the IP address or the management port of the switch, plus the switch itself. So I'm putting those ports SWP0 through 3 on a switch. And on port number 2, I'm using the TSN tool to, first I need to, based on the documentation for the NXP switch, the first thing you need to do is disable cut-through mode before enable preemption on switch ports, which is done here. And then after that, I set Q1 to be preemptible. So this 02 here corresponds to, if you imagine that you have 8 gates, and all zeros represent non-preemptive and 1 represents preemptible. So when you set that 1 to that number 1 on priority 1, that means 02 in hex. So that's why we represent it here. And as soon as you QBU set, you can go into your XP switch, which is below here, and you see as soon as you do QBU status for that specific port, you're going to see that it's active, and the preemptible value is 02, which corresponds to priority 1. And in terms of like how do we know that a packet got fragmented or preempted, there is a particular stats that we look at on the port itself, and that's the stats that is given by this value here, TX merge frames. So for all the stats on the port, you have this command here, but we're focusing on the TX merge fragments, which gives you the value that represents the fragmentation. So if nothing's going on there, you see that those values remain the same, so nothing is there. So I'm sending 8168 here is our baseline number before we do any testing. And before we do any testing itself, we can actually look at the forwarding database table, the MAC address table, to see if those MAC addresses got learned by the switch. In this case here, they have not. So as soon as I will start protocols here, so on the right side now, I'm on the right side, and I'm going to go and I will start protocols here. So after starting protocols, the IP addresses are going to ARP themselves out, and they're going to be able to find each other on the small network that I did here. So they're all part of the same, they're hosts on the same network. So after I do that, after I come up with my protocols are up, I should be able to go here now and look at my forwarding database table and find all my MAC addresses associated to those ports as part of my table. The timer for those tables, the database here for the learn, I think it's about 5 minutes, but you can extend that. There is ways for you to switch. Right now I set mine to 10 minutes, so you won't. The learn here, the MAC learn here is about 10 minutes. After I did that, I can go into my traffic now. So the first thing is that since I'm just brought this traffic up, and before I can actually start capturing, I have to go into my traffic and apply the traffic. Applying the traffic means that I configure the traffic. Now I'm sending down to the port level to the FPGA for the traffic. After that, I can just start traffic. So now the traffic got applied, and I'm going to go into the captures now, and I'm going to start a data capture on my port number 2, which is where I expect my packets, the fragmented packets, to come in. So at this point, the capture is on, as you can see here. I'm going to go into my traffic, and I'm going to start traffic. So traffic shouldn't run for that long. I have 10,000 packets express and 100,000 preemptible frames. And preemptible is going to start, and then 500 milliseconds later, I'm going to send my 10,000 express traffic and see what happens. So since here, you can see that all my traffic went through. I didn't lose anything. I can actually stop the capture here, so I don't have too many packets to look at. After that, I have about 100,000 packets collected. So first things first is going to go to the NXP switch and see if we see any the fragmentation number, fragmentation counter went up. So for that, we're looking at the SPW2 port number 2. The number now is 10,130, and used to be, based on our baseline here, used to be 8168. So fragmentations did happen. Now we have to look at what got fragmented. We can look at here before we're going to look at the capture. We can look into a little bit more stats for my traffic. I didn't lose anything. We can look at the latency, and you can see that By far, the latency of the preemptible traffic is a lot higher, which we did expect, since that is the traffic that's being impacted. And the traffic that is expressed, it didn't really change much. As you can see, the latency, the average was 4, the minimum was 2, and the max was 5. So it was pretty consistent. So very important to figure out here is that my critical traffic did not got impacted. And you can see here the preemptible traffic, the latency is all over the place now because I was preempting that traffic. So let's take a quick look now at the capture. So I'm going to open up the capture here really quick. And since we're already at 28 seconds here, we can stop this. So what I was expecting is that the 500 milliseconds later, I should be able to see introducing my express traffic coming in. So I'm going to take a look at one is 29,499, I think. Yep, it's precisely over here. So that's when I started my sending traffic. This here is exactly at 500 milliseconds later. So if you count the 28, 38 here and go back to the beginning here, this should be exactly about half a second. As you can see here now, the traffic that was non-critical at this point here, it was running flawlessly without any interruptions. And as soon as I start sending my critical traffic, the traffic now got interrupted, preempted. And you can see here that my traffic is, it's a bunch of Bs for the data. That's the data traffic for my preemptive traffic, all the Bs here. And then my express traffic, it's all A's here as my data, as my packet data here. As you can see here now, the fragmentation now, it's happening on the Bs, which is the preemptive traffic, which I was expecting. So as you can see here, this is the initial fragment for a frame. So it's a 1520 frame that got fragmented into 1, 2, 3, 4, 5, 6, and then it here starts again. So you can see that the packet here got this packet here, even though it's a non-critical, it's going through, but now it's going through in fragments, right? In 1, 2, 3, 4, 5, 6 fragments before the next one got also fragmented and being sent through. So this is where there's a competition here between the non-emergency traffic and the preemptible traffic. And after all my express traffic or critical traffic got through, you can see that the non-critical traffic kind of is sent right after that without any issues, without any more interruptions. We can also take a look at the statistics here and look at the conversations, and we see that all my express or critical traffic, it was sent across here, and the non-critical one did not. I stopped the traffic. That's why you see 51 here. It's not the full 100,000, but we know that that traffic also went through based on. So we send 100,000 here, and we got 100,000 at the. Okay, so this is all I wanted to show today. It's a short video.